This is physical science, and for today, we will be discussing about motion in a vertical plane, and then we proceed to projectile. All right. Now, motion in a vertical plane is also a straight line motion. Okay, vertical nga lang. Okay, so we can make use of the horizontal tawag dito, motion to describe vertical motion in the same manner. Pero before that, let us review muna ano ba yung mga pinag-usapan natin sa horizontal. Okay? So we started with velocity and sabi natin it is equal to x over t. So last week, we obtained a formula to measure acceleration. And then sabi natin, ano ba yung acceleration? It is a rate of change of velocity. Okay? So, yun. And then that equation and this equation, putting them together, okay, we come up with this equation here. Sa baba. Okay, pinakababa. This is x equals v sub it plus 1/2 at squared. Okay, now part of deriving this formula came from this. Okay? Kasi baka magtaka kayo, paano nagkaroon ng 1/2 doon. Alright? So, this is yung pag-derive natin doon. Substitute the values. Okay? But then, let us not bother ourselves for now regarding this, how we derive that because we're more after the concept. Okay? Kaya medyo conceptual din ang approach natin although there will be some practical application later on. Alright? So now this equation, x equals v sub it plus 1/2 at squared is a formula that describes displacement under constant acceleration. Okay, let me explain that further. So pag sinabing constant acceleration class, okay, it is the acceleration at a certain point of time. Okay, kasi mineasure natin yung change from initial to final. And then, yun yung mineasure natin ng time. And that would be the acceleration because of that. Okay, now, if toward the travel or the trip, nag-change ka uli ng velocity, okay, then it results to another acceleration. So, ang pinag-uusapan natin dito ng acceleration is at that point of time. Constant yung acceleration, but not during the entire trip or travel, kung nagka-travel man yan. Okay? So, with that, this is our formula to describe displacement under constant acceleration. And if you started from rest, okay, v sub I is 0, so this equation now is reduced to x equals 1/2 at squared. Okay? And then using this formula again, let us have a value for t. So t is equal to v sub f minus v sub I over a. And substituting that t for all the t's here in this equation, and then simplifying, okay, we have this final formula, which is x equals v sub f squared minus v sub I squared over 2a. Okay, now, since both are solving for x, then these two equations are actually formulas that will describe the displacement at constant acceleration. Alright? Kasi pareho lang yan, di ba? And if we rearrange this equation to this one, v sub f squared is equal to v sub I squared plus 2ax, then we have a formula that describes velocity at constant acceleration. Okay? And again, if started from rest, initial velocity is 0. So you have this final equation, which is, or formula, which is v sub f squared is equal to 2ax. Okay? So with that, now let's take a look at vertical naman. O, yung dinescribe natin kanina, nireview lang natin yung horizontal motion. Okay? So let's now move on to vertical. Okay? So in evaluating vertical motion class, it's much the same in the same manner that we evaluated horizontal because both of them are along a straight line anyway. Okay, so both of them are straight line motion. Okay, now the only difference is that in vertical motion, there's a great impact of gravity. Okay, so that is why the acceleration that we will be describing here would be the acceleration of gravity. And because of that, all bodies in free fall. Okay? So, that means gravity is the very reason why there are freely falling bodies. Okay? So, pag fall na sinasabi, it's vertical talaga. Okay? So, all bodies in free fall near the Earth's surface have the same downward acceleration, which is either 9.8 meters per second squared or 32 feet per second squared. Okay? And a body in free fall has the same downward acceleration whether it starts from rest or has an initial velocity in some direction. So, you see that class, di ba? So, whether it started from rest or started with an initial velocity or at a certain direction, the acceleration would remain the same for downward or for vertical. Okay? For vertical, tawag dito, motion. Okay? Because the acceleration is when an object is um, in free fall. Okay, so, but the presence of air affects the motion of falling bodies, partly through buoyancy and partly through air resistance. Okay, and because of that, two different objects falling in air from the same height will generally not reach the ground at exactly the same time. Okay, yan, because of that. Right. Now, if we neglect buoyancy and air resistance, a falling body has a constant acceleration, which is the acceleration of gravity. Okay? So, kaya nga, there's a constant value for gravity, which is symbolized by G. So, G is either 9.8 meters per second squared or 32 feet per second squared. These values class are equivalent. Okay? Equivalent sila in the sense that they are expressed in different units. Okay? Yeah. Now, take a look at this. Okay? O siguro, let's move on to the next na lang, yung table. So, you can see clearly, okay, para mas maliwanag. Yan. Okay. So, this is a table comparing uh, ways to describe or estimate or measure horizontal motion, okay, as against vertical motion. So makikita nyo pareho lang ano, 'di ba? May acceleration, acceleration din. Kaya lang ito, for any change in velocity, if there's a further change aside from this change, okay, then this acceleration will change also, 'di ba? But here, kahit anong change niyan, the same ang value ng G. Okay? And here, we're talking about the horizontal distance or displacement. Here, we're talking of a vertical distance, which is height. O, di ba? Okay? So, halos pareho lang. Right? So, I hope you remember this. Alright? Okay. So, moving on, let us have sample problems to illustrate vertical motion. Okay, number one, a stone dropped from a bridge strikes the water 2.5 seconds later. What is its final velocity in meters per second? Okay, so with that, our working equation is V sub F is equal to GT. Okay? Ito galing sa V sub F minus V sub I equals GT. Okay? Pero bakit walang V sub I? Because the stone was dropped. Simply dropped. Okay? Sa horizontal, it's the same as starting from rest. Okay? And take note that for the value of G, I use 9.8 meters per second squared. Why? Because the problem specifically asks us to express the final velocity in meters per second. O kasi pag gagamitin natin yung isang value ng G, mali na. Mali, kasi magkakaiba ang unit eh. Diba? Okay, so solving for that, we obtain 24.5 meters per second. Okay? Now, another question could be, how high is the bridge? Ayan. So, using our formula for height, which is equal to 1 half gt squared. So, solving for that, we get 30.6 meters. Alright? Okay, so another example, what velocity must a ball have when thrown upward if it is to reach a height of 15 meters? Okay, look up here. When we throw an object upward, okay, so let's take a look at the upward direction. Kasi when it reaches a maximum height, okay, uh, it stops to rise and it begins to fall. Di ba? Kasi upward eh. Di ba? So, vertical yan. Okay? So, the initial velocity would be, kung ano yung velocity na inihagis mo siya pataas. Okay? And then, as it goes up, okay, it slows down. Okay? Ayan. Until it stops to rise. Okay? So, the upward direction, the initial velocity is kung may value. Kung halimbawa, 60 kilometers per hour or 60 meters per hour or per second. Halimbawa lang. Okay? At the maximum height, the final velocity would be 0. Okay? Alright. Now, at the maximum height, it starts to fall. And when it starts to fall, it's like it's just being dropped from a height. Okay? So from there, the initial velocity in falling down is 0. Okay? Until it reaches a final velocity downward. Now, look up here. The upward direction, the initial velocity is kung ano man yung value niya, and then the final velocity is 0. Okay? But the initial velocity downward is 0. Okay? So what do you think would be the final velocity? If the final velocity in going up is 0 and is equal to the initial velocity in going down, which is 0, then the initial velocity must also be equal to the final velocity. Tama? Okay. So, it's the same thing. Kasi, look up here. In going up, the final velocity is 0. Ito yung equation natin. 0. Okay? So, now, sasabihin nyo ay negative. Oh, wait. Remember, gravity is always directed downward. So the downward acceleration of gravity is assigned a positive value. So kung upward yung motion vertically, you assign it a negative value. So kung negative yan, negative doon, then you still end up with a negative, okay, initial velocity. Okay? So now, if for the downward, okay? O, wala problema. Positive yung G. And then, yung initial velocity mo is 0. So, this one proves that the initial and final velocity are equal. Okay? Ayan. So, with that, we can now solve for the final velocity. It is the final velocity that is being asked. Okay? Oh, what velocity must a ball have when thrown upward? Okay. So, equal lang yan, di ba? Initial. So, kung yung initial yan, the same. Okay? So, solving for that, we get 17 meters per second. Okay? And with that, we're now ready to discuss projectile motion. So, ano muna yung projectile? A projectile is an object launched into space without motive power of its own, which travels freely under the action of gravity and air resistance. Okay? It travels under the action of gravity and air resistance. So, ibig sabihin, it should not, pag sabing without motive power, dapat walang motor o walang makina, ganyan. Kasi kung meron nun, edi hindi na freely moving or freely traveling. Okay? The object is no longer traveling freely. So, the traveling freely is the requirement for an object, okay, that is projected upward, horizontally, or in whatever direction, okay, for it to be called projectile. Okay? All right. Now, if we neglect air resistance, okay, so the object, once projected, continues to drop only by the downward force of gravity. In other words, the only force acting in a projectile is gravity if air resistance is neglected. Okay? All right. So let's take a look at this figure. Ayan. So these are the different types of projectiles. Okay? So anything na nilagay mo sa ere, okay? Okay, above the ground, it becomes a projectile. All right? So yan. Okay. And let us yan, diniscuss natin yung straight line motion starting with horizontal and then uh, vertical motion. Now, the formulas for the straight line motion, we can use them to analyze the horizontal and the vertical aspects of a projectiles fly. Okay, so to better understand that, let's take a look at this figure. Okay, so here, let's throw an object horizontally above the ground. So it has to be at a height above the ground. Okay? For it to move freely. Kasi if it's on the ground, edi horizontal motion lang yan. Straight line horizontal motion, hindi projectile. But once above the ground, if you throw it horizontally, okay, as it moves horizontally, it also drops vertically. Okay? So the total horizontal motion plus the total vertical motion downward is equal to this projectile path. So, yun yung projectile path natin. Okay? So, ibig sabihin, unlike the straight line motion na pinag-usapan natin, we cannot just add or subtract. No? In the same direction, add. In opposite direction, subtract. Here, it follows itong path na ito, which is very, very similar to this figure. Okay? You remember this? Yung hypotenuse represents our projectile path. The adjacent side represents the horizontal aspect, okay? And the opposite side represents the vertical aspect, okay? So to get the sum o kung total niyan, kung ilan man yan, okay? You always get the sum of the horizontal and the vertical components, but not in the way that we add a straight line motion, okay? Remember, this is what? So, iba yung mathematics nito. It is trigonometric. Okay? So, uh, to give you a complete picture, let's have this complete projectile path. Okay? So, if we launch this projectile at this initial velocity ng V sub O, class here, from the source I obtained this figure, okay, the initial velocity is given the symbol V sub O. Okay, pero pareho yun ng ating V sub I. Okay, so don't be confused. Alright? So this one has a horizontal aspect and a vertical aspect. Okay, so using trigonometry, let's see how we can get the horizontal aspect. Okay, so now we're ready to, so by the way, before I continue, ito yung complete projectile trajectory. And this is the maximum height that it could reach. And this is the range of the projectile. The range is the horizontal distance covered by the projectile. Okay? Yan yung horizontal distance. Okay? So now let's take a look at the components, the horizontal and vertical components of the projectile. Okay? So starting with the initial velocities or initial velocity components, V sub O. Okay? So that's why we say the V sub OX, V sub OY. V sub OX to mean the horizontal aspect of the initial velocity. V sub OY means the vertical aspect of the initial velocity. And we get this, okay? O kasi here we are looking for the adjacent. Kasi adjacent side based on trigonometry divided by hypotenuse, we have a cosine function. Okay, so that is the angle theta with which you have launched the projectile into space. Okay? Alright, so nasaan yung initial na yan dito sa figure? It's that part here. Yan. Okay? Now, after time t, saan yun? Here. Okay? Ayan. Meron lang initial at may final velocity doon. So, we're looking now for the horizontal and vertical aspect of the final velocity. Okay? So, the horizontal, since horizontal siya, kita nyo dito, lahat ng horizontal pare-pareho. Okay? Hindi naman kasi nabago yung yung velocity. Yung all of them are along the horizontal. Okay? And they were not since horizontal, not much yung impact ng gravity. Okay? But it's the downward motion that is affected by gravity. So now this equation galing dun sa similar sa G, di ba? G is equal to V sub F minus V sub I over T. So ano yung V sub F? Ano yung V sub I in terms of this? Okay? So yun. V sub O cosine So ito yon. That's how we got it. Okay? All right. So using trigonometry, all right? And then at the maximum height, okay, what would be the x component? Saan yung maximum height? Here, at this point here. Okay? So still, the x component or the horizontal aspect is still v sub o cosine theta. O kasi ito yan eh, buong yan eh. Kung ito yung buo, di ba? From here to here. Yan yung buong horizontal aspect. Okay? O kung kukunin natin itong triangle na ito, yan yung buo, di ba? That's the whole. Okay? That's one half of the projectile path. Okay? And one half of the range. Okay? But it gives you the height. Okay? O kaya at that point, the y component is 0. Okay? And again, the x component is still, okay, v sub ox, which is v sub o cosine theta. Okay, now, if this is 0, then we can transpose that gt on the other side. So we have this formula, and we can use this to get a formula to estimate the time the projectile will reach the maximum height. Okay? Kasi just like kanina, doon sa vertical, the time to reach the maximum height is also the time to reach the final velocity. Okay? So, yan yun. Alright. So, at the end of the flight, dito na, here, okay, notice that it's the same as the initial velocity components. Okay? The only difference is that the y component is given a negative sign because it is opposite of the initial velocity y component. Okay? Ito is going up, ito is going down. Okay? It does not indicate yung gravity direction class, ha? It is in the motion of the opposite ng initial velocity. Okay, yun yung ibig sabihin nun. All right? And with that, okay, so if this is the formula to estimate the time to reach the maximum height, and then if we say that the time to reach the maximum height is equal to the time to reach the final velocity, okay, then the total time of flight must be twice this one, okay? So that we have this equation or formula, which is T is equal to 2v sub o sine theta over g. Okay, so this is the formula to get the total time of flight of the projectile. Okay, now what about the range? How do we get the range? Okay, so the range is a horizontal distance covered by the what? Tawag dito, covered by the projectile. Okay, but then sa horizontal, it is simply x equals vt. But again, we cannot use that in that manner kasi nga we're getting the range for a projectile, di ba? So the velocity here must be the horizontal aspect of the projectile, which is v sub o cosine theta, and then the total time of flight is 2v sub o sine theta over g. And when we substitute these values here, okay, we get this theta. Okay, may nagtanong, bakit daw sine ang ginamit? Di ba? O dapat ay cosine theta, sine theta. Okay, now, you review your trigonometric identities. Di ba? So there's an identity that says cosine theta, sine theta is equal to I think if I remember it right, 1/2 sine 2 theta. Okay, so instead of using cosine theta, sine theta, we use 1/2 sine 2 theta. At bakit nawala yung, walang 1/2? Kasi may 2 doon eh, di ba? 2 multiplied by 1/2 is 1. Okay, so we're left with this equation. Okay, so yan yung ating formula to solve for the range of the projectile. Okay? All right, so I hope that is clear. Okay, so now moving on, let us summarize the two formulas. This here, this gives us a summary, and these are the formulas to evaluate a projectile. Okay, projectile path, projectile motion. Okay, all right, so with that, let us have a sample problem. An air rifle is fired at an angle of 60 degrees above the horizontal. If the pellet's initial velocity is 40 feet per second, how far does it go? And what is its time of flight? So for our solution, for letter A, it is actually asking for the range of the projectile. Okay? Now, since theta is 60 degrees, then 2 theta is 120 degrees. Okay? Kaya we substitute there sine 120 degrees. Okay? And then we substitute the initial velocity, which is 40 feet per second. Okay? And then we square that. And then notice, here I use 32 feet per second squared because the initial velocity is given in feet per second. Okay? And then solving out, we get 43 feet. All right? I hope that's clear. Now for letter B, again, it's asking for the total time of flight, and using our formula, we have that. Substituting the given data and solving it out, we get 2.17 seconds. Okay? Is that okay, class? Okay? O kanina, may mga nagko-comment. May nagko-comment. Yung mga, ma'am, cancel out po yung second squared. Yes, here. Kasi this becomes fit. Pag ginawa mo yung square niyan, it becomes 40 times 40, tapos magiging feet squared per second squared. Okay? So yung second squared and second squared here would cancel out. And then since naka-square yung feet dyan, matitira yung isa. And isa dito maka-cancel out. Okay? So the same thing here. Okay? Naka-square yung second. So yung feet per second here would cancel out. Sa feet per second here, matitira ay second. So you have the unit na second here. And here, it is feet. Okay? So very good naman. May mga estudyanteng napapansin pa yun. Very good. Okay? I really appreciate. I appreciate those students. Napapansin nila yung mga maliliit na bagay na yun. When in fact, hindi talaga pwedeng baliwalain. Kasi with the units, kung medyo nalilito ka sa solution mo, okay, work on the units. If you end up with a wrong unit, okay, after canceling out, then probably your solution is wrong. Okay, so that could be one check. All right, so that's it. That ends our discussion